Hello everyone, I am a PhD student at Charles University in Prague and I work at the Institute of Hydrodynamics of the Czech Academy of Sciences, where I'm working on my research. I focus on drinking water treatment, especially on the removal of algal organic matter. And at this conference, I would like to present to you the results of ozonation and coagulation of non-proteinaceous fraction of AOM. The next step in my research will be advanced oxidation processes in drinking water treatment and their impacts on natural organic matter. And now, let's look at the ozonation of AOM. AOM is increasingly produced in water sources due to the intensified eutrophication. It can be a problem for technology of water treatment, but also for the final quality of drinking water. And how big this problem can be was the main goal of this research. The composition of AOM is very diverse, but most often contains proteinaceous and non-proteinaceous fraction, which can be up to 80% of AOM. And with an increasing portion of non-proteinaceous fraction of AOM, our problems with water quality also grows because the removal efficiency of non-proteinaceous fraction is only up to 25% compared to the proteinaceous fraction, which can be up to 82%. The reason for low removal efficiency of non-proteinaceous fraction is probably caused to the high content of low molecular weight or uncharged organic substances, which can be precursors of disinfection byproducts. So, the question is, how do we increase the removal efficiency of the non-proteinaceous fraction? And the answer can be in oxidation processes, especially in pre-ozonation or post-ozonation. Firstly, we focus on the effect of ozonation alone of the non-proteinaceous fraction. The concentration of dissolved organic carbon of non-proteinaceous fraction was 5 mg per liter, and the dose of ozone was 0.05 to 4.0 mg per liter. The ozonation pH included acidic, unaltered, and alkaline condition. The next step was pre-ozonation with coagulation. The non-proteinaceous fraction after ozonation with a dose of ozone 0.05, 0.5 and 4.0 mg per liter was coagulated with aluminium sulfate as a coagulant agent with a dose of 10 mg per liter of aluminium at a pH range of 5 to 9. Finally, we tested coagulation with post-ozonation. At first, the non-proteinaceous fraction was coagulated under optimal conditions, which were 10 mg per liter of aluminium at the pH value 7.0. Then followed post-ozonation under conditions same as for pre-ozonation. How I said, firstly we focus on the influence of ozone on the character of non-proteinaceous fraction of AOM of green alga chlorella vulgaris. In this picture you can see that the effect of ozone alone on the concentration of DOC of this fraction was very low, only 5%. But ozonation of a non-proteinaceous fraction had a significant impact on the molecular weight distribution. You can see that the low molecular weight compounds increased after ozonation, and conversely, the proportion of high molecular weight compounds decreased. Unfortunately, a high portion of low molecular weight compounds can be a problem because coagulation does not like low molecular weight substances. So, let's go and see what's happened with coagulation after ozonation. And look at this. In the case of pre-ozonation with the dose of 0.05 milligrams per liter of ozone and ozonation pH 5.5 and 7.8, the removal efficiency increased throughout the range of coagulation pH. It was probably caused by a change in the charge properties of the non-proteinaceous fraction from uncharged to charged. On the other hand, the pre-ozonation with the dose of 0.5 milligrams per liter ozone caused a decrease in the removal efficiency almost in all tested pH values. Probably it was caused only by a change in molecular weights of organic substances and not by a change of surface charge. Thus, there was no oxidation of the functional groups of organic substances to carboxylic acids, which would increase the efficiency of coagulation. On the contrary, the dose of 4.0 milligrams per liter of ozone and pH ozonation of 9.0 caused an increase in the removal efficiency of the non-proteinaceous fraction throughout the range of coagulation pH again. This increase in the removal efficiency was probably due to the non-selective radical reaction, which was caused by the decomposition of ozone under alkaline condition. Although there was an increase in the low molecular weight substances, there was also a change in their surface charge, which was probably the cause of a higher efficiency of coagulation. As the last step, we tried to ozonate it of non-proteinaceous fraction after coagulation. The removal efficiency of coagulation itself was only 15%, but coagulation post-ozonation had increased the removal efficiency by another 6%. It was probably caused by the mineralization of low molecular weight compounds which were present in the sample after coagulation. The highest removal efficiency was caused probably by the reaction of non-selective radicals in alkaline conditions. In conclusion, I would like to highlight that ozonation causes changes in the molecular structure and has little effect, only 6 or 7%, on the removal efficiency of the non-proteinaceous fraction of AOM. And yes, probably it is not the best technology for the removal of non-proteinaceous fraction, but it is the technology that we use in drinking water treatment as pre-ozonation and post-ozonation or disinfection. Therefore, it is very important we operated the water treatment plant in optimal conditions to prevent the possible formation of undesirable substances such as aldehydes or disinfection byproducts, and thereby degrading the quality of drinking water. Thank you for your attention. See you soon.